Hi. Now in this question we're given three horizontal forces acting at a single point, have magnitudes of 12 newtons, 14 newtons and 5 newtons, and act along the bearings of 000 degrees, 090 degrees and 270 degrees respectively. And what we've got to do is find the magnitude and the bearing of their resultant. So if you'd like to have a go at this question, haven't done so already, just give you a moment to pause the video. Do come back when you're done and you can check your work solution against mine. Okay, well let's see how you got on if you had a go. Well, first of all, what I'm going to do is draw a diagram and we'll have north, say, up the page here, okay? So what we've got is all of 12 newtons acting upwards on a bearing of 000 degrees. So we'll have that as all of 12 newtons. And next up is 14 newtons acting on a bearing of 090 degrees. So that's going to be in an easterly sense. So that's going to be 14 newtons, say, in that direction. And finally, we've got 5 newtons acting on a bearing of 270 degrees. So that's going to be from north, turning 3/4 of a turn round in a clockwise sense. So that's going to be 5 newtons that way. Okay? Now we've got to find the magnitude and the bearing of the resultant of these three forces. And I can see that, or sense anyway, that we've got more force to the right here and slightly upwards. So that resultant force is going to be somewhere in this direction. I'm going to label it as R. Now to find R, what I'm going to do is to split this into two components. One horizontally, let's say that's X, and another one vertically. We'll say that that one there is Y. I'm going to work out what X and Y are by resolving forces, and once I know what X and Y are, I'm going to use Pythagoras' theorem to find out what R is, because I can redraw this just down below, that if I know X and I know Y, then that force of R, resultant, comes from this triangle of forces. Okay, so I can easily do that by Pythagoras' theorem. And also, as for the bearing of the resultant, that will be this angle in here. We'll call it theta. So in other words, if I've got the north direction there, then theta is this angle. And this is alternate to this one here. So from this triangle, I can work out what theta is if I know X and Y by just basic trigonometry. So that's the route I'm going to take for this problem. So first of all then, I'm going to resolve now to the right. So we're looking at the resultant force then to the right. And that is going to be X. But X is equal to all of 14 newtons, that acts to the right. Then we've got minus the 5 newtons, because that's in the opposite sense to the way I'm resolving. As for the 12 newton force, well, that doesn't come into this equation here because it's perpendicular to the direction I'm resolving, so it has no effect in this direction. So 14 take away 5 tells us that we've got 9 newtons acting towards the right here. Okay, next I'm going to resolve upwards, taking upwards as positive, and we've got Y is that resultant force we're saying, and Y must be equal to just the 12 newtons, because the 5 and the 14 are perpendicular to this direction, so they have no effect in this direction. So now that I've got X and Y, okay, I can use Pythagoras' theorem. we've got that therefore that resultant must be equal to the square root of the sum of the squares of these two shorter sides, x squared plus y squared. In other words, 9 squared plus 12 squared. And this comes to the root of 225, which is 15. We don't need plus or minus, we're just taking the positive value, okay, because it's a length there. So that's going to be 15 newtons. As for the angle theta, just got to use basic trigonometry. The tan of theta would compare the opposite side over the adjacent side. So tan of theta equals x over y. And so therefore I can take the inverse tan to both sides, so I get theta equals the inverse tan of x over y. X is 9, y is 12. And if I work that out on the calculator, that angle theta equals 36.869 and so on degrees. So therefore, in summary, what we've got is that the resultant, okay, must be 15 newtons. And as for the bearing, well, if I give this as a 3-figure bearing, it's going to be 0.37 degrees, okay? That's the angle in here, and that is to the nearest degree. So we'll just put to nearest degree. Okay?